All right, good morning. Hope everyone's doing okay today. All right, well, so I would like to talk about the next ODP and then go back and talk about the ODP we just finished and go through some discussion about debugging because there's a lot we can do with debugging that I think we're missing in some cases. So I want to talk about that for a little bit and then go on and talk more about the dialog command and dig into some deeper Unix commands, touch on awk a little bit, and kind of go from there. So questions up front. So let me say this again because I'm still seeing this. When you're trying to convert integers to strings, don't use atoi. Don't use scanf. Okay, scanf can get you into all kinds of issues with looping and infinite loops and things like that. Don't use atoi. It doesn't do error checking for you. Okay, unless you're doing extra things outside. If it doesn't find a valid integer, it'll just return a 0. And you don't know if the person input a 0 or input something invalid. Learn to use scanf. Okay, it will be incredibly useful to you down the road. If you haven't figured out scanf yet, spend some time, play around with it, ask questions, and so on. Let's see, I'm a bit quiet. Okay. Let me hop into Zoom. Let's see what it's doing to my audio. Testing. Okay, hold on. Let me change my audio and change it back. Alright, so that usually does the trick. Alright, it seems to sound good to some people. Cool. Hey, we could do a vote and see if my volume's okay or not, but we know how well that works. Sorry. Alright. So yeah, make sure you're friends with scanf. Okay, it will really simplify things down the road. So any questions? All right, let's talk about the next ODP first, and then we'll go back and we'll talk about the one you just turned in. All right, so we're doing ODP 415. And this is another string processing assignment, but it's different from the ones we've been doing before. The ones that we did yesterday and Monday, we were building a new string out of an old. For 415, we're processing an input string, and we're evaluating it as an arithmetic expression, and then calculating what that expression is equal to. So you're writing a function in C called calc. It takes a string, it returns an int, and this one actually does return an integer value that matters. So the argument should be a string with no spaces in it that looks exactly like this: a number, an operator, and a number. Okay, number must be an integer, could be positive, negative, or 0. Operator must be a single character, plus, minus, star, or slash for add, subtract, multiply, divide. And your function should interpret this as an arithmetic operation. Okay, so there's some examples at the end here. For example, if your string is 9 plus sign 9, it should evaluate that as 9 plus 9, return 18. If it's 9 star 8, it should return 72. So it does arithmetic, right? 23 plus 45 returns 68. 23 minus 45 returns minus 22. All right. So the intended behavior when everything is correct is pretty straightforward. It's just a basic calculator. Okay. It's an integer calculator, so 132 divided by 11 returns 12. 1 divided by 3 would return 0. Okay. Don't do anything special. Don't round. Don't convert to doubles and take floors or ceilings or anything. Just work with integers. Take your two numbers as integers. If you're supposed to divide them, just do, num1 divided by num2, and whatever that returns, that's the value of the function. Okay? Most of these ODPs, the fancier you get, the harder it's going to be, and the more likely you are to misinterpret what's going on. You want to be as fancy as the written description says you should be, but then don't try to, second guess and say, oh, this would be better if it did floating point or something, because it won't assess. All right, so error handling. So you want to parse the string using scanf with %d, %c, %d. Okay, and since you're trying to scan 3 things, that should return the number 3. If it does, you've got an int, a character, and an int. You're good to go. Okay? Don't worry about extra stuff at the end. Don't worry about anything fancier than just scan it with %d, %c, %d. Make sure it returns a 3. Okay? If it doesn't match this pattern successfully, return a -1. If it does match this pattern, meaning it's an int, a character, and an int, but that character is not one of our 4 legal characters, then return a -2. So your only options are return the value of the calculation, which, could be -1 or -2 also. Return the value of the calculation, or if scanf doesn't return 3, return a -1. Or if scanf does return 3, but you don't recognize the operator, return a -2. And so lots of examples here. 9 equals 8 equals not a valid operator, returns -2. Ha plus ho, those are not integers, returns -1. Okay, 2.3 returns -2 because period is not a valid operator. That's all you need to know about the ODP, okay? Do it exactly like that, you'll get 100% on it. Okay? Most likely, if you start messing with this, if you start trying to do something different to parse, you're going to get into trouble. You're welcome to do that, and when I show you a way and I say this will work, I'm absolutely not discouraging you from trying to find your own way to do something or from exploring what other things do. You got to do that, right? That's how you're going to learn the stuff. My point in giving you pseudocode or talking you through an implementation or giving you something like this is if you want to find a way that is guaranteed to work, right? That's what I'm trying to give you here. But it doesn't mean you shouldn't explore, right? You shouldn't try to find something that works for you. And most valuably, if you think something should work and it doesn't, right, you want to dig into that. Don't just throw it away and say, oh, I guess I have to do it this other way. I don't know why. Don't ever do that, okay? In computer science, if it makes sense, it should work. And if it doesn't, either there's something slightly off with your understanding, or there's a genuine bug somewhere. That's always possible, or something. But if it makes sense to you and it's not working, drill down into that. Okay. All right. So any questions about this? Yeah, add asterisks until you stop getting pointer errors, or add curly brackets. All right, so let's talk about yesterday's ODP. And so I sent out an announcement and suggested some ideas for debugging, and some people wrote back and said they tried what I suggested, and they were able to figure out that they had a problem and then resolve it. Anytime you're monkeying with strings, anytime you're playing around with null terminators, right, you run the possibility of making a mistake in doing that. And if that goes wrong, and you're testing one string, you might get lucky, and your program. Hold on a second. Your program might work perfectly. But if you have a string and it's not null terminated, right, that string basically continues until you bump into a zero in memory. And a lot of times, there's a lot of zeros in memory. And sometimes things get initialized to zero. But if you run multiple test cases in a row inside your program, and in particular if you alternate between long and short test cases, and try a few non-empty test cases and then try an empty one, and kind of mix it up, right, you may be more likely to find bugs. And so one thing I mentioned in that announcement was, it's really helpful if you can find a test case that breaks your code. Okay, and that's sometimes a question of, how good are you at coming up with test cases, and how aggressive are you in trying, different cases in different orders to break the code. And if you write your code and you look at it and you think it looks great, go ahead and assess it. That's okay. If the assessment comes back and you're not getting 100% on it, there is a test case somewhere that will break your code. Okay? And deliberately, I'm not giving you those test cases. Right? If I gave you a main program and showed you the source code for it, you would get, pretty good at debugging your functions that you were writing. But part of what I want you to do is get really good at exercising those functions, finding those bugs, coming up with test cases, and learning about the different situations where code can break. All right, so having test cases will help. There's something else we can do, and so this is something that I just call playing computer. So basically pretending you're a computer and that you are executing your code and seeing what happens. And if you do this correctly, this is, for some cases, more powerful than GDB for debugging. Okay? And hands down, this is the number one thing that I do when I'm looking at code. This is what I do anytime that somebody sends me code and I want to know, where the problem is. This is what I do when I'm writing my own code before I, compile it. And this is what I do when I bump into problems. I'll go to GDB if there's something really big or I don't know where the code is, but for shorter segments, this is the go-to tool for figuring out what's going wrong with a program. So, so let's play with some examples of this. So let me hop over here. Give me one sec. All right, so here's a sample snippet of code for moving the first character of a string to the last. So this was yesterday's ODP. And, the sentiment is straightforward. We're going to take the first character and we're going to save it somewhere, okay, because we're going to shift down this input string. So I copy the input string to the output string. So now out's an exact copy of my input. And then I go through a loop, and for each character in my input string, I set the corresponding character of the output to the following character in the input. So if my input string was hello, going to set my output string to hello originally. That's what that string copy does. But then I'm going to go through and I'm going to set each character of out to be the following character of in. So I'm going to go like this. And then when I'm done, I'm going to set out I equal to save, which should take my saved character, which was H, and pop it down there. All right, so let's play through this as if we're a computer. And there's a trick to doing this, and it's kind of a temporary suspension of belief. When you're doing this, you have to forget about what the code is supposed to be doing. And you just have to look at each line and do exactly what that line of code says without thinking about the bigger picture. So don't think about this as I'm copying my saved first character to the end of my output. All right? Forget that. Just take save, look at the value of I, copy it to that position in the output array. Right? So if you've done Engineering 270, this was something you had to do in debugging your code there. If you haven't done 270 yet, right, this will help you with that. So let's just dutifully go through here and let's pretend that we're a computer. So I'm going to set in equal to, I'm just going to go with a 3-character input. A, B, C, null terminator, and I'm going to list question marks after this because I don't know what's in those other positions. And the first thing I see in my function here is integer I. Okay, so I'm going to set I as an integer, and I'm going to set its value to question mark. Okay, that's important because until we initialize it, we don't know what the value is. Now, if I've got code that starts using I before I initialize it, I'm going to see that right away. I'm going to say, oh, I'm trying to index element question mark, and you found your problem. All right. All right, so set save equal to in bracket 0. So save is equal to, well, here's my input, bracket 0 will be the character A. All right, string copy out from in, so out is going to be A, B, C, null terminator, and then a bunch of question marks. And then let's go into our for loop. So now we're going to set I equal to 0. And we're going to say out 0 equals in 1. Okay, let me write down the string length of in while we're here. And it's equal to 3 because string length doesn't count the null terminator. So it's going to set out 0 equal to in 1. So in 1 is a B, so this is going to change to a B. That's good. And then we're going to go back to the top of the loop. I is going to get incremented to a 1. And now this statement right here says out bracket 1 equals in bracket 2. Well, in bracket 2, so this is bracket 0, 1, 2. In bracket 2 is a C. Out bracket 1 is right here. This is going to change to a C. Good. And then we're going to increment I to a 2. And we're going to come back up, and 2 is less than the string length of in, which is 3, so we're going to execute this loop one more time. And this says out bracket 2 equals in bracket 3. Okay, in bracket 3, that's the null terminator. Out bracket 2 is right here. This is going to change to a null terminator. Now we're going to increment I once more to a 3. We'll come back up here. 3 is not less than the string length of in, so we'll exit this loop. And now we have one final statement we execute. Out bracket I equals save. Well, I is equal to 3. This is 0, 1, 2, 3. This is going to change to our save character, which is an A. And there's your output string. And very clearly, this is not what we wanted, right? Okay, this doesn't tell you how to fix it, but if you go through this exercise and then when you're all done, you step back and say, so did my program work? It's like, nope, it lost that last character. Okay, so now you go back through and you do this again, or maybe you switch to GDB now that you know what you're seeing, um, and you say what was supposed to happen. Okay, one other important thing to keep in mind here: don't just fix your particular bug. Right? I might look at this and I might say, okay, so let's set out bracket I minus 1 equal to save instead. Well, does that make sense? I mean, it would fix this case, maybe. Oh yeah, and I got to throw a null terminator on the end, right? But don't take your buggy code and try to add more stuff to it to fix it. Try to back up and figure out where that bug was introduced, and then change the way you wrote the code so that you don't introduce that bug. All right, so that's one example. Let's look at one more example. All right, so what's the idea of the move function here? We're going to look at the length of the input. We're going to save that last character. Let's see, I don't even need that save. All right, so here's my move to function. Wow. Here's my move to function. So basic setup. I'm going to save the length of my input string. I'm going to have an output pointer, which we talked about yesterday, and as long as that's less than the length of the input string, I'm going to set the next character in my output to the following character in the input, and I'm going to bump up my counter. So basically the same thing that we were doing a little while ago. And then I'm going to set my last character in my output to the first character in my input. Okay. So let's go through and let's pretend we're a computer again. So input equals A, B, C, null terminator, and then a bunch of question marks. And our output is just a bunch of question marks to begin with. All right, in len is the length of the input string. So that's 1, 2, 3, doesn't count the null terminator, that's just 3. Out is assigned a value in its declaration, so we know out's equal to 0. And then, while out is less than 3, we're going to do the following. Output bracket out equals input bracket out plus 1. So again, output 0 gets the value of input 1. So I'll put indices on top. Pretty hard to see. But output 0 gets the value of input 1. So this first character changes to a B. And then we say out plus plus. And we go back to the top of the while. And it says is out less than in. Yes, it is. So we'll go into the while loop again. We'll say out 1 equals in 2. So that changes this to input 2, which is a C. And then we'll increment our output variable. All right, 2 is still less than 3, so we're going to do our while loop one more time. And we're going to say out 2 equals in 3. So output 2 is equal to in 3. That's a null terminator. And then we're going to increment our output. And we'll go back to the top of our while loop. 3 is not less than 3, so we kick out. And now we do our final assignment. And this one is written very carefully. Output in len minus 1. So that's output 2 equals input 0. So output 0, 1, 2, that's this character. is going to get assigned the value of input 0. That's an A. And then we return. And what is our output string? It's B, C, A, followed by a bunch of unknown characters, right? It's not null terminated. We did copy a null terminator. The last time through the loop, we picked up input out plus 1. That was the null terminator, right? Input 3 got copied to output 2. But we didn't put that null terminator in the right spot. Again, don't try to tweak the code now. Try to go back and redevelop the code while avoiding what happened here, right? Now, when I ran my test code, you know, it looked like it worked great. ABC changed into BCA. Well, chances are that, you know, there was something sitting after here in memory. This question mark was probably a 0 to begin with. And we just kind of lucked out. But if we can do something like this, right? Now it's glaringly obvious what's going on. I tried to move A, it should have made an output string of A, but it had the leftover stuff from my previous call to move. It was just kind of sitting around in the machine's memory, and those question marks didn't happen to be null terminators. So if you had started with test cases like this, then that would have jumped out at you. But even if you didn't, right, going through and pretending you're a computer and figuring out exactly what happens in each line leaves you with, you know, the undeniable conclusion my output string is not properly terminated. All right, so those are some things to keep in mind for the ODPs, but for code in general. All right, so questions on any of that? All right, so let's talk more about the dialog command. And by the way, I haven't heard from anybody as far as what groups they want to form for homework 7. I have heard from some people who said they don't have a group and they're looking to join a group. So send me an email, you know, as soon as you've either decided, you know, who you're going to work with, or if you don't think that you have anyone particular in mind, send me an email with your name, tell me you're looking for a group, and I'll get people together. Sooner is better because you want to get going on this as soon as possible, right? Because it's due a week from Friday. And ideally, you know, you get together early with your group, figure out how you're going to break things up, and then each person can start working on it at their own pace. All right, so let's play more with dialog. And I want to talk a little bit also about how to process some of the outputs that we'll get from this command. Let's just look at some more of the commands we can do. So I showed you a text box. Oh, that's way too long. All right, so there's my data file. So we can do a dialog text box, data.text, and put in your height and width, and there's your data file, right? And if this is large, then you can scroll through it. We looked at that yesterday, and you can look at it and then hit the exit button when you're finished. But we can also do an edit box. And this brings up a window that not only shows you the contents of your file, but lets you edit it. And it's rudimentary. And I just made it disappear. That was freaky. Okay, I don't know what that was about. So it's a rudimentary editor, right? And our question answer program that we've played with a little bit is built on top of this. With an edit file, once you finish and you click the OK button, it outputs the contents of that file, right? So if I say something like x equals this thing, and remember I broke my terminal. Remember we had this trick, output -fd1. So if you run a dialog command and you say --output -fd1, then the result that comes back from that command will go into standard out and can be captured inside back quotes. So if I do this, and let's say I make some, I'll add some change here. Now if I look at the value of this variable, it's the contents of the file, right? And it's all slammed together on one line, but we can deal with that later. So the edit box does not actually change the contents of a file, but it shows you the contents, it lets you make changes, and then when you exit the dialog, it gives you that modified file as, a presentation to standard out. And so we can use that to do some rudimentary editing of files. We can make checklists. Well, let me just grab one. I already created one of these. So I'm going to do dialog checklist. You can put in a title. 0, 0 is, just take the default height and width. And then 3 says how many lines I want in my checkbox. And I can basically put a label next to each of these. No, an edit box does not change the file. It gives you, to standard out, a copy of the file with the changes. But the original file stays intact. Alright, so checklist, title, height and width, number of rows I want, and then for each row I list 3 things, which is a pair of labels, first in A, default B, last in C, and then the keyword off or on to say whether that box is checked by default. And so if I run this dialog, I've got 3 options to choose from. First is A, default is B, last is C. And I can, hit a space bar to select or deselect. I can use arrow keys to go down through, and so on. And then when I exit this dialog, it outputs the values of this first column to standard out. So again, if I do something like x equals back quote, --output -fd1 end back quote. Well, I can go in here and I can select, let's just select first and default. And then if I look at the value of that variable, it's got a space separated list of the items that I selected. All right, this is how pretty much all these dialogues are going to work. So you have a dialog command with options to create a widget that the user can interact with. And if you want to capture the output, put this output FD on the end. If you throw the whole thing in back quotes, you can assign the result of this widget to a variable. And then in your bash script, you can do whatever you want with that. And you can do a radio list, and a radio list is like a checklist, except you can only have one thing selected at a time. So when I select something, the previous selection goes away. Alright, so it's like an old radio buttons in a car. And then if you look at the value that was returned, it'll be the value from this column of whichever item you selected. We can do an input box. So dialog input box, put in a title, and then put in, you know, height and width, and you get a box that you can type into. And as usual, the result of this dialog command, the output it produces, is whatever the person typed in. So if we want to save this, throw the whole thing in back quotes, specify the output file descriptor as 1 at the end of the command, and you know, there's my name. And that got saved in a bash variable. So now you can take that and do whatever you want with it. Alright, these are the pieces of your calendar program, basically. Right, enter a description of the appointment. Well, you can pop up an input box and the person can type in the description, and you can grab it in a variable and then throw it into a file next to the date. And how do you get the date? Just pop up a calendar widget. Alright, so one more example. And there's really tons of these things. So we can do menus. So here's a menu dialog. The title is just going to say choose, right? Default height and width. A total of 3 menu options. The first one will say make an appointment, the second will say show day, the third will say show all. And if I run that, I've got a menu I can pick from. So I can scroll through menu options, I can hit, you know, the number 1 to choose menu item 1 or menu 2 and so on. And then when you exit out of the dialog, it returns the value of the item number that you selected. So one more time, if I want to capture that selection, save it in a bash variable, I can, you know, say variable equals back quote, type in this whole thing, dash dash output FD 1, and now yeah, I want to show all, so I'll type in a 3 and say OK, and this variable has that value in it now. Alright, so that's a basic idea. Again, take a look through the manual page, at least figure out what type of information is available where in here. Most of these things can be customized. You can add back titles, you can set the aspect ratio for the display. You can put multiple widgets together. You can have one appear as soon as the previous one ends. You can make the default value no instead of yes. You can change the names of the buttons. You can add a third button to most of these dialogues. You can show a help button, right? Extra buttons, all kinds of options. If you're doing a calendar, you can change the format in which the date comes out. This is a really general purpose tool. Okay, so there's lots of features available. Disable the mouse if you don't like mice. Change the separator, so if it's going to output multiple pieces of information, you can specify something other than a space as a separator. And this is kind of classic with Unix in general, right? Most of the tools that you encounter are pretty powerful, right? The sort utility, for example, has lots of features to it. grep has lots of features. ls has lots of options available. Dialog has lots of options available. But remember, in Unix, you can put commands together. So if I wanted to take the output of my ls command and sort it in a particular way, there might be a switch that I can find in the ls command itself. But I could also just take the output of ls and put it into the sort command. And if I'm really good with the sort command, I might know, how to reverse the order of the output, and decide to use that. So you don't need to learn all of this stuff, inside dialog, but at least, take a perusal through and see some of the general things that you can do. Just to kind of have some options in mind. So there's lots of general options in the beginning, and then there's specific things that you do, calendars, checklists, and so on and so forth. You can do file selection dialogues. If you want the user to specify a file, you can pop up a widget where they can go through their directory and find files that way. You can create forms, which are more complex than a simple input box or a yes/no box, but the same idea. Different ways of displaying information: info box, message box, and so on. There's progress bars. There's a password box that you can type into and you don't see what you type. So if you want someone to type without someone behind being able to read what they're typing, you can do a password box. There's progress bars that will, show you how much of 100% you're at, and just all kinds of options. Probably more than enough for what you might come up with for homework 7, right? Well, I mean, that's never true, but you can always want more. But for any reasonable features you might decide to implement in homework 7, it's probably pretty slam dunk. Just finding the right combination of switches in dialog. But it goes on and on. Alright, and this is cool. If you want to know how to use the different options, they recommend you look at the source code. So, that's good. And if there's something you really hate about this, you can make your own version of dialog. All right. Questions, comments? All right. Let me talk really quickly about awk. We're going to spend a day or two playing with awk, but let me start an introduction to that. So let's say we're running a dialog to show a calendar, and we'll say November 25th. I think that's Thanksgiving. All right, and I captured my output and I threw it into a variable x, which looks like this. And the default format it's using is day/month/year. And that may not be, you know, the format that we actually want. But let's say I just want to know what month the person selected. There's lots of ways that I can grab this month field in here. One really easy way to do this is to use a command called awk. And awk is really made for processing lines of data as a set of fields. So if you have, you know, a file, and you can think of each line of that file as being a collection of fields, things that are separated by some delimiter, and you want to process that in some way, there's a good chance awk will help you. So if I want to break this up into, you know, a year and a month and a day, that's a question of taking this thing and breaking it into, you know, these three fields. Okay, so let me just show you a really simple awk command. So I'm just going to say awk, and I'm going to say print $2. And I'm going to type in some input. So without a file name, this reads from standard in. So I'm going to say this is a test, and it prints out is. With the what, it prints out the. A, B, C, D, E, it prints out B, B, B. So what is it doing? On each line of input, it's printing out the second word, is the B. So if I had something like 25/11/2020, this would print out that middle field, the field 2, which in this case I'm thinking of as the month. Of course, if I do this, there is no second field because my fields are separated by spaces. But I can change that. So this is one of two switches I know for awk. Dash uppercase F followed by a character says that's the delimiter I want to use. And now if I say 25/11/2020, it gives me that second field because now my fields are separated by slashes. So this is a test, is just one field, but this is a test separated by slashes. The second field is. And so if I want to pull out that middle field from my bash variable x, I can do the following. I can echo $x, but I can pipe that into awk f slash and say print the second field. And if I want to save that in a variable, I can say month equals, quote, all of that stuff. And then when I look at the value of that variable, there's my 11. Alright, so that's a really quick preview, but we're going to play a lot with awk and sed, which is another counterpart to awk. But punchline there for now, right? There are ways to take outputs from commands and manipulate them and change them into different shapes that we might prefer to work with. All right, so I'll leave it there. I will see you next time. Have a good one.